Welcome back, students. In this video, we're going to do Module 7, Topic 5, Rhombi and Squares. This is page 13 of the Module 7 packet. Let's see, scooch up here to the warm-up. So this one, let's see, determine whether each pair of lines is parallel, perpendicular, or neither. So this is going to be a kind of warm us up into some. We're going to use this in this lesson. So, number 1 says line containing x, 8, negative 3, and y, negative 4, negative 6. And line containing r, 113, and s, negative 3, negative 3. So we're going to use the slope formula. That's y sub 2 minus y sub 1, x sub 2 minus x sub 1. Let's see, let me just... Since I put the formula right there, we're going to do, so we're going to start with this guy and get the slope here. So our y's are negative 6, negative 3, so negative 6 minus negative 3. And our y's are, our x's are negative 4 minus 8. So negative 6 minus negative 3, so this is like negative 6 plus 3. So negative 3 on top, and negative 4 minus 8 is negative 12. It's going to make 1/4. So we're getting into our formula there. Excuse me. 1 second. Okay. So, pardon that. All right, so our slope for this first line is 1/4. So we'll scooch over here for this next line. So R and S. Shoot. Hold on. Let me get this. Now, try to keep our color straight here. Okay, so over here we got. Let's see. All right, for this next line, y's are negative 3 minus 13, and then negative 3 minus 1. Gives us negative 16 over negative 4. That breaks down to positive 4. So the negative 4 and positive 4, those are not that's not the negative reciprocal. We need that for the perpendicular line. To be parallel, they have to be the same. So for these guys, I'm just going to write it in between. They are neither. Goodness, if I could write. So those two. All right, so let's see, we'll change colors here. So for the second line, I'll scooch down too. We have AB. So negative 4 minus negative 1 on top, and then 3 minus 2 on the bottom. Gives us, that's like negative 3 plus 1, so it's a negative 4 plus 1, so it'd be negative 3. And on the bottom we have 1. So this is negative 3. Let's see, change to blue over here for our CD. So we got 0 minus 6 for the y's, and then 3 minus 1 for the x's. So negative 6 over 2, which is negative 3. So this is negative 3, and this is negative 3. So this is, they're parallel because we have the same slope. Okay. And then down here, number 3. Y equals 2x and 2y equals negative x. So let's see. We need to divide both sides by 2. So this negative x would be negative half x. This would be negative. So this is negative 1/2, and that is positive 2. Those are negative reciprocals because that's the same as this, right? So this one is perpendicular. Okay, makes sense. All right, scooching down the page again, page 13. Properties of rhombi and squares. So a rhombus, that's a parallelogram, it has 4 congruent sides, like my friend right here. All the properties of a parallelogram hold true for a rhombus, including the following 2 theorems. So everything we talked about the last couple of days with parallelograms goes, but we're going to add these 2. So theorem 7.15 says if a parallelogram is a rhombus, then its diagonals are perpendicular. So remember, for the rectangle, the diagonals were congruent and they also bisected. So here, these guys are perpendicular. So the fact that they're perpendicular, the diagonals make a 90-degree angle. All right, 7.16. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So the way those, 2 diagonals will cross, they'll bisect these angles. A little different than the rectangle and the parallelogram we've been talking about the last couple of days or last couple of videos, if you're learning this way. All right, and then lastly, a square. That's a parallelogram with 4 sides and all 4 angles congruent. All of the properties of parallelograms, rectangles, and rhombi apply to squares. For example, the diagonals of a square bisect each other like a parallelogram. They're congruent like a rectangle, and they're perpendicular like a rhombus. So it's a special parallelogram, it's a special rectangle, it's also a special type of rhombi. So, square is the special of the special in our quadrilateral family here. We'll have 2 more we'll cover in the next module, but the square is the crown jewel here in geometry world. All right, so let's flip over to page 14. I'm going to use some of these properties to solve some problems. So I've just got a practice problem at the top. It says TU is 5 feet. TUS, so this angle up here is 30 degrees. And SV is 4 feet. Find the measures of UV right here. STU here, and US. So this guy. Okay, so we'll just see. Did it say, was TS one of these? No, US. Okay. I think I may have marked the wrong ones. Okay, anyway, so we got 5 feet here. UV is also going to be 5 feet. It says STU. So over here, so let's see. Give me just 1 second. These are perpendiculars. This makes a 90. So 90 plus 30 is 120. So this guy over here, 120 minus, no, wait a minute. Yeah, 180 minus the 120 here would give us 60. So that's STU now, US. So US. So we have a right angle here. So this is a right triangle, so a squared plus, no, this was c squared. This is our hypotenuse. So for US over here, where it's going to be US, this is our a squared. It's going to equal c squared minus b squared. So this is going to be 5 squared minus 4 squared, which is 25 minus 16. So that's 9. A squared is 9. Take the square root. And A is going to equal 3, which this is SU. So let me just cross this out. So US, excuse me. So US equals 3. STU equals 60 degrees. And US right here below. Oh, and UV equaled 5 feet. So let me just put those out there. And this is 3 feet. All right, let's go down below here. All right, number 1. If LM equals 2x minus 9. And Kn, let's see, Kn equals x plus 15. In rhombus, KLMN, find the value of x. All right, so let's see. What do we know about a rhombus? I'm just going to flip over. All right, so diagonals are perpendicular. So we have right angle, right angle, right angle, and right angle. They bisect each other, so this, and this. Let's see. And we also know that all four sides are congruent. So we're going to say 2x minus 9 equals 5x plus 15. I'll get you guys in a habit, let's go through what do we know, because it's asking us about a rhombus. All right, so I'm going to get rid of the x over there. 2x minus x is x minus 9 equals 15. Add the 9, x equals 24. Okay. All right, number 2, in quadrilateral, WXYZ is a rhombus. So again, tells us what we're dealing with. If AZ equals 2x minus 1 and AX equals 3, find the value of x. All right, so it's a rhombus. We know that these diagonals are perpendicular. We know the outsides are congruent. And let's see, let me just double check. So we know that the diagonals bisect each other. So we know this guy and this guy are equal, are congruent. So 2x minus 1 equals 3. Plus 1 plus 1. 2x equals 4. Divide by 2. X equals 2. Easy peasy. So this quadrilaterals is probably one of the easier modules. So let's see. All right, number 3. Find the diagonals of rhombus, again, rhombus, KLMN, intersect at P. If the measure of angle LMN, so LMN, this guy, is 75 degrees, find the measure of angle KNP. So this guy down here. All right, so let's see what we're doing here. Let's see. No. All right, so if this guy is 75, the diagonal bisects the angle. Just going to make this green. It'll make it a little easier. So this side, half of 75 is 3750. So it goes the same for here because they're congruent. So I'm just going to kind of make this like that. All right, that's important because, so in the middle, all these are 90-degree angles. So if we're trying to find this guy here, so if these are 3750, this guy is going to be 180 minus 90 minus 3750. I'm sorry, 37 and a half, I keep saying. All right, so handy dandy calculator. So 180, of course, minus 90 is 90. Then we go 90 minus 37.5. So that makes this angle 52.5 degrees. Okay, because same, triangle down here. So that makes, see, this splits this angle. This does the same here. So if this side is 52 and a half, see, they're congruent just like these two were. So the measure of angle KNP is going to be 52.5. know that one may have been a little harder to follow. Hopefully not. If you have any questions, let me know. All right, number 4. Quadrilateral WXYZ is a rhombus. Again, and I'm not going to underline it again. Find the measure of angle. Let's see. What it gives us WYZ. So, wow. Drop my pen. Hold on. WYZ. So, down here. So, this guy is 35 degrees. So, this guy is also 35 degrees. Okay? We know it's a rhombus. So, we know the diagonal splits that angle. Now, we also know these guys are all 90-degree angles. So now it wants to know, let's go green, WXZ. So here. All right, so triangle is 180. 180 minus 90 is 90. 90 minus 35 is 55. And of course these are congruent, so that means the measure of angle XZ is 55 degrees. All right, let me just readjust the camera. Excuse me. There we go. All right, number 5. EFGH is a square. If FG is 19, find EH. All right, so EH. Okay, let's see how. Wait a minute. Give me just one second, guys. Hold on. Okay, sorry about that. So, and I kept saying FG, it's FJ. FJ is 19. That makes this guy 19 because they bisect. They're also congruent, so that makes this guy 19 and this guy 19. So let's see, I'm going to change colors, but we have 90-degree angles. Okay, and last but not least, yeah, so just making sure. So these guys are all 90-degree angles. So we have let's see. Hold on, one more thing here. Hold on. I'm going to show you 2 quick things, and I'm trying not to make this video any longer than it already is, but so we want to find EH over here. Notice all these in the inside are all 19. This is a 45, 45, 90 triangle. Now, this is something we're going to learn Module 9 when we get into the little bit of trigonometry we do. So, anyway, 45, 45, 90, real quick, means, so this is 19, this is 19. The rule is if these guys are X, well, they're the same as what that X represents. So I can show you that these are both 19 for our example here. Well, these are both the same number, and this one is that number times the square root of 2. And if we use the calculator, I'm just going to put it in the screen here, my phone. So the 19 times the square root of 2. So I'm going to say square root 2 times, oops, wait a minute, let me close the parentheses. Hold on, let me just do it this way. 19 times square root 2 equals, so you see it's 26.87. So that is going to be the answer. I'm just going to go ahead and write that over here for you. Now, so like I said here, so for 45, 45, 90, these two sides are going to be equal, and this is going to be whatever this is times the square root of 2. You saw the calculator that was the case. So looking over here, if we do it the way we've learned so far, Pythagorean theorem, a squared plus b squared equals c squared. So we have 19 squared plus 19 squared equals c squared. So let's do this here. We'll use it again. So 19 squared, oops, wrong button. Beep, 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 beep. 19 squared plus 19 squared. So it gives us 722. That's c squared. That's EH squared. We want the square root of that. What do we get? 26.87. Isn't math cool? So, two different ways to do that. We get the same answer. So 19 squared plus 19 squared was 722. We take the square root, and then c squared, or EH, equals 26.87. Okay, sorry. Now that took way longer, but I got to show you some little preview of next module, and that makes me happy. Anyway, so number 6. PQRS is a square. QR is 7. What's QT? So QR is 7. What's QT? So we'll do this again. These are our 90 degree. You know, I always have been drawing the box red, but as long as we got the box. So we got 90 degree angles there. Let's see. So we know that, let's see, a squared plus b squared equals c squared. So we're just going to call this x, because this is also x. They're the same. They're congruent. You know, remember, the diagonals are congruent. So a squared plus b squared equals c squared. So 2x squared equals 7. We got to square that. Excuse me. 49. All right, so divide both sides by 2. You get x squared equals 24.5. Then we're going to take the square root. So we get x equals we're going to round it 4.95. So x, or QT, I'll just say QT, is 4.95. Okay, moving on. Page 15, and just double check. Yes, that's it for this particular topic. I'm going to try to hurry, but I want you guys to get the right info. So, getting a little more complicated, as you can tell, even though it's a square, and squares are, you know, have all these rules, and, you know, it's the more rules it has, and square is simple, you know, 90 degree angles, all sides congruent, all that good stuff, but it invites more opportunity, and that's why we're doing further, you know, our problems are getting a little tougher. So, in rhombus, PQRS, so PQ is 4x plus 3, and QR is 41. The measure of angle PQT, so this guy, 2x plus 4y. Okay. What do we do? Let's see. Okay. All right, so what must the y value be for the rhombus to be a square? Okay. So, well, first let's find x. You know, I told you guys we're not going to find x and y at the same time. So, let's find x first. We got an x here. We got an xy here. So, let's find x first, and then we can figure out what we need y to be. So, this is a rhombus. You know, the square and a rhombus, they're both going to have congruent sides. So we're going to put 4x plus 3 equal to 41 to solve for x. So we got minus 3 minus 3. 41 minus 3 is 38. Those cancel. 4x divided by 4. X is 9.5. Alright, so now we have this guy here. Now, in order for this rhombus to be a square, these have to be 90-degree angles. So we put, let's see, we're going to put 2x plus 4y equal to 45, because we need it to be, we need this to be a 90-degree angle to make this rhombus a square. And in order for this to be 90, that means this bisects it and makes it 45. Well, it's a rhombus that would bisect it in that angle anyway. So let's plug in, what do we say? 2x was 9.5 plus 4y equals 45. So 2 times 9.5, that is 19 plus 4y equals 45. Get rid of that, get that 19 over there and get rid of it. Boom. 45 minus 19 is 26. 4y equals 26. Divide both sides by 4. Y is going to equal 6.5. There we go. All right. We finish off. We got 4 theorems and a problem, and that's it for this topic. So, test for rhombi and squares. Theorem 7.17 says that the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of the parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. If 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. If the quadrilateral is both a rectangle and a rhombus, then it's a square. Okay, all that being said, scooch down to the bottom here. Number 8. Determine whether quadrilateral ABCD with vertices, and it gives us the coordinates. We'll graph it and then we'll solve it. We're going to determine whether it's a rhombus, a rectangle, a square, or none. List all that apply and explain. All right. So A is -3. Sorry, -3. Yeah, +2. B is -2, +6. C is +2, +7. And D is 1, +3. All right, let's get a compass here. Oops. There. One second. Okay. One of my better drawings, and I know there aren't many. So, what we need to do, we can figure out, we can look at this and pretty much eliminate rectangle, but we're going to mathematically do that by using the distance formula to check to make sure the 4 sides are congruent. That'll nail us down to rhombus and square, and then we can just check the slope, and it will tell us, we'll check the slope of the diagonals, and that'll tell us if this is perpendicular or not, and that'll tell us if it's a square or if it's a rhombus. All right, so, all right, let's start with A and AB. So over here. So distance formula is the square root of y sub, let's see, well, that's all right. You guys know this, hopefully. If not, then you need to come see me. So the square root of y sub 2 minus y sub 1 plus x sub 2 minus x sub 1 squared. So we have for AB, we have negative 2 plus 3 squared plus 6 minus 2 squared. So if you go negative 2 plus 3, that's positive 1. Positive 1 squared is 1, plus 6 minus 2 is 4. 4 squared is 16. 1 plus 16 is the square root of 17. Sorry, trying to keep my writing going, but also keep my mouth going. All right, let's go with CD next. All right, sorry, I'm gonna try my best to keep this going and not run out of room. All right, so for CD, we have 1 minus 2 squared plus 3 minus 7 squared. 1 minus 2 is negative 1. Negative 1 squared is 1. 3 minus 7, negative 4. Negative 4 squared is 16. 1 plus 16 is square root of 17. Okay. So we know at least A, B, and C, D, which I guess we could have checked there. But anyway, we'll just keep going. BC. So we're up here. Should have drawn these in this color, but oh well. All right, so we got 2 plus 2 squared plus 7 minus 6 squared. So 2 plus 2 is 4. 4 squared is 16. 7 minus 6 is 1. 1 squared is 1. 16 plus 1 is 17. Let's go back to red again for the last one, DA. So bottom here. Got negative 3, negative 1 squared plus 2 minus 3 squared. So negative 3, negative 1 is negative 4. Negative 4 squared is 16. 2 minus 3 is negative 1. Negative 1 squared is 1. So remember, anything squared is positive. If 2 negatives squared make a positive. If it's under here, it's going to be, if it's negative 3 squared is 9. So just stop it for a second. Anyway, 16 plus 1 is negative 17. So we definitely have a rhombus or a square. We can definitely eliminate rectangle now. So next step, we need to find the slope of BD and AC to see if, or we, wait a minute. AB, actually we can find the slope of the AB and BC to see if this is a 90-degree angle, and that'll tell us it's a square or not. All right, so let's see if the slope for AB and BC are perpendicular or not. Of course, the slope for two perpendicular lines, the products are negative 1. So let's get AB first. All right, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for AB, we have 6 minus 2 on the top, negative 2 minus negative 3 on the bottom. So 6 minus 2 is 4. Negative 2 minus 3, so that's like negative 2 plus 3, is positive 1. So 4 over 1. So the slope for AB is 4. So let's see if the slope for BC, if it's a negative 1/4, then we have a square. If it's not, we have a rhombus. So let's see what we got. 7 minus 6 on the top, 2 plus 2 on the bottom. So we got positive 1 on the top, positive 4. So that's positive 1/4. So this is not a negative reciprocal. These two together do not equal negative 1. So they're not perpendicular. So this is a rhombus. And let me just scooch down. So scooching down, this is a rhombus. And why? Because the diagonals are not perpendicular. All right, guys, that's it for one night. If you have any questions, let me know. Until next time, have a great night.